Today we are pleased to have Catherine Plaisant from the University of Maryland. She's part of the Institute for Advanced Computer Studies there, where she's the Associate Director of Research for the Human-Computer Interaction Lab. She is a very, very well-known person in both information visualization and HCI. We had invited Catherine to give a lecture last year back in December.
Oh, really?
She was so busy that this was the earliest that she could come. And she is very well known for her work in information visualization and HCI. She's the co-author with Ben Schneiderman of the 4th and 5th editions of the Designing the Human User Interface, which is a major book in HCI. And we're very pleased to have her talk about some of her recent work with medical records. So please join me in welcoming Catherine Plaisant.
Hi, thank you. Thank you. I'm really honored to be here. I'm impressed. What a room. Thank you. And it's after lunch, so I'll try to keep you awake. Don't hesitate to stretch and all. And maybe we could even say if there is question in the middle, don't hesitate, and we'll speed up if needed at the end to end in time. So the Human-Computer Interaction Lab is, like you, very interdisciplinary, but mainly people from computer science, information studies, and psychology. And we do a variety of things that have nothing to do at all with the kind of thing you are doing here, who might involve working with children, working with elderly, worrying a lot about social media and how to motivate people to volunteer for things, or, for example, just to say a lot of diversity. So actually the group that is doing InfoVis is pretty small. It's mainly Ben Schneiderman and I and a few students. And I'll try to give you the best idea of one slice of what we have done on electronic records. But first, a little introduction to the power of information visualization. Here is a typical example, and people, you show this data set, 4 data sets, the 4 colors. Can you tell what's different? The curves of the color, okay. What's the same? Was anything weird about those data sets? All right, I'll speed it up a little bit, but they are, here, like they are all the same value. Whoops, if I could go straight on my mouse, except for one. And then there are some weird things, like this column here is the same as this one. And actually this one too. So there are a lot of things, but it's hard, it takes some effort. So people say, oh, no problem, run some statistics. And they all have exactly the same statistics, those 4 columns. But when you look at them, suddenly they are completely different. And you could make a lot of inferences about what this means, what's really is it an error or is it an outlier? Does it mean something? So just if you look at it and you could see something. So it doesn't mean that statistics are no good, obviously, but we want both. We want to do both at once. So when we think of information visualization, we think of it as a graphical representation, but also a user interface. You know that saying, a picture is worth 1,000 words? But we think that an interface is worth 1,000 pictures. So we could do a lot more. We want to be able to play with your data and explore it and look at it different ways so we see more than just one picture. Again, nothing wrong with the one picture, but we like the interface, and that's what really we focus on. So you may not see, after seeing your demos this morning, I'm like, oh my God, my screens, my visualization are not that beautiful. But what we do is more like we make it easy for people to manipulate them and find things in the data by exploring it. So we've done many different projects, but I won't go over them. Just pick one because I know not everybody knows about InfoVis. So we are very famous for the tree map. The tree map, the idea, and that's the application that made it famous, is every box is a stock in the stock market. And the size of the box is a market capitalization. The color tells you if it's going up or down. You could change the color. There's blue and green if needed, but this is the standard. Green is good. And let's pick and they are clustered they're grouped by market area. So this is healthcare, mostly green that day, some red. But let's pick a different day. Anything like that's clearly very bad, right? We're not doing well. What about this one? Could you see something funny in this set? It's pretty bad, but we could all pick up that little spot there, right? So it makes it easy. And because it's grouped hierarchically, and here is a very simple hierarchy, it's only 2 levels. I mean, really, so you could tell which groups are doing well, which one are not. And so this little tree map, somehow it's everywhere. More and more people are using it for different things. And for example, in the medical informatics, like recently we learned at FDA, that's how they look at the data. You know, they get all the reports that come from everywhere about the adverse reaction to drugs, and they are organized in some hierarchy, and they look at display like this. They look at redness. The more red it is, the more there is more reaction for that drug than it's supposed to be compared to all the very fancy statistics. And so they could organize by all the cardiology area, the health, the pulmonary, whatever. So whatever hierarchy you have, you could display your hierarchical data in such a tree map. And at a glance, boom, you get a view of how we are doing. All right, so that's a perfect example of an information visualization that is fairly simple and has been growing, find growing use. But today we're going to focus on temporal data. And just very simply, there's simplifying 2 types of temporal data, numerical and categorical. And we've done some work in the past on the numerical, but, and here is, actually, I thought I would show you that little demo, if it's still there. Takes a little while. Oh, no, where did I put it? So that's not what worked, but that's also an excellent example of the interaction making power. Here is a timeline of the use of different baby names over time. So we have many years here, from the 1880s to 2011. And you can see the names that are used a lot. So stacked bar chart, James. But really what the power of this tool is when you start typing. So for example, let's look for Crest. So I type C. Now I see all the C names. See Charles is used a lot, and Christopher, and so I type H. All the names that start with like this are Christopher. Oh, here we go. So I'm afraid you're not that popular anymore. So it's just another example of the power of really exploring. And what they have seen is it's an extremely simple interface. You just type a name. And the people have documented, the people who developed this tool have documented how it's been used in many, many different ways, that people have arguments for days or around, type this letter and you see what effect it has and how it changes. And it makes it extremely easy to explore this data. But that was a very popular example again. If I go back to my slide, for some reason it takes a few seconds to switch. No. There we go. So we have done some work on numerical data also. Like one example was a time searcher. I won't demo it here, but what it did is it allow, if you overlap all the time series here, it gives you the envelope, but you were able to draw some boxes and then another one, and it would filter automatically by only the timelines that went through that box. So you could very easily draw something that says, so I want all the lines that started high and then it ended low. Or you could pick an example that would draw around boxes around it and you could move them dynamically very quickly. Or here's the similar example where you could draw a box around this piece of the timeline and it would find you all the other places in all the other timelines where it appeared. And that's an example where what makes it hard. What does it mean to be really the same? Here we had several parameters to tweak. So what does it mean? Is it absolute size? Is it shape? There are many ways to be similar. But today I'm moving out of the numerical. I'm going into the categorical data, where really each event is something like here is something from a database from an hospital, where you have the patient arrive at the hospital, he goes to the emergency room, he goes to the ICU, the intensive care unit, then he goes back to a normal room, that's a floor, and he exits, for example, is discharged, right? So those are categorical events. And that's from now on, that's the only thing we're going to be talking about. In some cases, people have taken numerical data and transformed it into categories like you could have blood tests being low, medium, and high, or normal and abnormal, for example. And practically, we found example in many different domains of electronic health record, as I said, but we've worked with traffic incidents, how quickly the folks in the highway department clean up the accidents, or education, students arrive, they take classes, they write papers, they change advisors, they graduate eventually. So there are also a series of events, and people have used the same tool I showed you today for this kind of data. All right? So going back in time, again, try to show you a little bit the history of what we have done. In 96, 98, we worked on Lifeline, where the idea there was to look at a single patient record. So this seems very simple by now, but the idea is that you had a timeline, you could zoom on it, and you had different facets. So here we had all the notes, the hospitalization, the tests, the medication, and this is a fake data set, as you could guess. But you could see all like this person was obese, all the checkups, the atrial flutter, some problem with the heart, the flu that became the pneumonia, etc. You could see she's pregnant. Here is the baby. So all those things acted as a giant menu. You could click on anything and get the details. And at that time, there was barely anybody had all that data in one place. So it took a very long time before anything like this actually came to being used. But and also it had things like you could zoom in and out, and with semantic zooming, where you would say, for example, you had this person was taking beta blocker, and as you zoom in more detail, you would see the individual drugs and the dosages. Right? So that was many years ago, and for a while we didn't do anything with the electronic health record. But 10 years later, we came back to it. Oh, actually, that was a controlled experiment, just because that's what we like to do. We like to put our users in front of screens and see, okay, what can you answer those questions? So we were comparing exactly the same data. This was another application domain, actually. This was juvenile justice data. All the kids that get caught by the police, they get a record, and you see all the things they are done. Same data, and we would show it visually or with a table, and it makes a dramatic effect of how much faster could people answer the question related. Of course, all the question related to time. Who was taking care of this kid when he went to prison? And dramatic difference. Also, better recall. People who see the diagram on the left, you show it for a few seconds, you put it away, they remember what they've seen, while on the table, they don't remember. Also, there was the first impression. That was a tough one. We would say, sorry, there is only one place in the jail today where we have two kids that possibly could go. We show them the record, the two record, and then we would see how good a choice they would make. So if you give them a few seconds, which is typically what happened, they pick the wrong one. And if you, with a table, they couldn't tell really as well how difficult the cases were. Well, the visual summary was more powerful. So it's very simple, but it's never hesitate to try to measure how much it makes a difference. And sometimes it doesn't. Sometimes we think it's going to make a difference, and we can't show anything. Alors, so that was Lifeline. And 10 years later, we get to, things have changed. Now there are databases, warehouses full of electronic patient record data. Now, how could we look at many at once? So that's, so I'll show you briefly a series of tools we have done. One, we search for similarities, and more important, we developed a tool called LifeFlows that tried to summarize all those patterns. And all along, we started really with the Washington Hospital Center, because sadly enough, the University of Maryland in College Park doesn't have the School of Medicine is in Baltimore. It's like an hour away. And somehow, you are lucky here. You could work closely together. This is very important, and take advantage of it. So I'm going to start by the tool called Lifeline 2, where, again, we're going to be looking at categorical data. And you might think, what happened to the episode data? So in this version, we don't do it. I'll come back to it later. Now, not yet. What we have is a series of events. So for example, pneumonia is a series of diagnosis of pneumonia. You don't know if they had it in the middle. You kind of have to decide depending on the spacing. But we'll come back to that. So the tool called Lifeline 2, I'll show you a video. Really, you'll see is really, it uses a series of very simple operators that are aligning, there are ranking, filtering, and summarizing, and that individually don't do much, but when we put them together, let you do very complex queries, really, and explore your data in a fairly powerful one. And one of the first ones seems trivial, but it's extremely powerful, is the alignment. So if you have two patients like this, and if you allow people to decide what they want to align by, then they'll be able to see patterns in a more clearer way. So the medical scenario, as I'll try to simplify, is when you go to get some radiology done, they make you drink something, and sometimes it creates some problems. So you could have what's called contrast-related nephropathy, and the effect is being seen, the negative effect is being seen through some blood test for creatinine. So if you have high creatinine, there is possibly something wrong as a reaction to the contrast you have ingested. And it appears 14 days later. So this is an example of thing that hospital institution might be asked to look for. How are we doing? Do we have a lot of those cases? Only a few? Who are they? And eventually in the future, you want to catch it before it happens, etc. So what we're going to see, one thing you want to keep in mind, because I know you deal with big data sets. What we tend to do to have all the interaction, it tends to be smaller data sets. So what we do is we do first a rough query on a huge data set, and then we throw it in our visualization tools. So I'm going to start the video, which shows the example of contrast-related nephropathy. Let's see it somewhere here. No, this one. And let's see. Don't move. Up, it'll make it big.
In this demo, I'm going to show how to use Lifelines 2 to find patients who experienced decreased renal function, possibly as a result of the administration of their radiology contrast procedures. This is indicated by their creatinine high events within 2 weeks after a radiology contrast. Here I have loaded a data set of 3,598 patient records. Each record is represented by a horizontal strip containing the patient ID and the events in the patient's history. Each event is represented by a colored triangle on the timeline. From the legend, I see that creatinine high, normal, and low are in red, blue, green, respectively. Scrolling down, I see that radiology contrast events are in yellow. To examine this data better, I align the patient records by their first radiology contrast events and rank by the number of creatinine high events to bring the most severe patients up top. I immediately realized two things. One, some patients have chronic renal deficiency and they should be removed because their condition is not related to their radiology contrast. Two, some patients have more than one radiology contrast event, and this needs to be taken into consideration. To remove the chronic patients who have at least 4 creatinine high events prior to a radiology contrast, I choose to filter by the number of occurrences on creatinine high. I set the number to be at least 4, and the filter scope to be before the alignment. The blue highlight indicates that these records are selected. For our purposes, we want to remove them. I click on Remove Selected and also save the remaining records as a new group. Let's call it Non-Chronic. Next, instead of aligning by every patient's first radiology contrast, I align by all radiology contrasts in all patients. Lifelines 2 asks me whether I will proceed as some patients will be duplicated. I click on Proceed. Then I bring up the distribution of creatinine high events across these records and zoom into the granularity of days. As I drag from day 1 to day 14, I'm selecting all patients who have at least one creatinine high event within 2 weeks after any of their radiology contrast events.
So it's already pretty
This time
complicated.
I
as
will
a
click
query.
on Keep Selected and save these records as another group. Let's call it Candidates. Looking at this group, we see that this is more of an overestimate. Many of the patients do not exhibit patterns of contrast-related renal deficiency. It would be better if we restrict only patients who have a baseline of normal creatinine prior to their radiology contrasts, without creatinine high events in between. To do this, I will use a sequence filter, specifying only for patients who have at least one creatinine normal reading, followed by no creatinine highs, followed by radiology contrast, and finally followed by at least one creatinine highs. Likewise, I'll click on Keep Selected and save this as a final group. Finally, this gives us 157 records. And visually scanning this group, these patients exhibit more prominently the patterns of contrast-related renal deficiency.
I'm going to stop here. But so what I hope you saw is that I could go in and do that query directly from the beginning, but really practically what happened is that people start with a simple query, I mean, what they think is the right query, and then when they look at the data, they say, oh no, there's all those other people I didn't think of. It's really, so there is that iterative process of you search a little bit, you see what you get, and you realize that you need to change and modify your query as you go. Yes?
So looking at this interface, so what happens if you have a lot of records, low ones, right? So basically, now you have you can scroll down, check each of them, but do you have automatic ranking and recommendation function doing so that the one with more promising matching patterns?
Right. But so part of it is that you don't know at the beginning what's more promising. So what we do give some ranking from the number of different events. Later on, you'll see some similarity and the aggregation. So hopefully what you'll see later might help you along. Right? But mainly what I wanted to see, it seems so simple, but practically the query that is at the end is very complex, and people, we tried. People can't do it in SQL. There is no way. And then what's important is that it changes as you go, as you look at the data. So we'll come back eventually. So maybe there was oh, that's interesting. It didn't put it back. And so again, those small, simple tasks that are combined into complex queries. And the idea is that you start with something small. In that case, the queries that was asked in the database of the hospital is find me anybody who had a contrast given to them and who had ever had a creatinine test. So then it narrows down to a patient that had even chance. But then there is no way you could do the complex queries on the whole database because they are very hard and it would take forever, actually, also. So the next level is, here is an example of the query that you would have to type. And we gave it to people who just took the class, and nobody could get it. So most people gave up before the end, or they didn't get it right. So the other example is that, so the physician we were working on, they were developing those extremely complex Excel forms to specify, with each column having formulas like this, to do something such simple as finding bounce back. The idea is that the patient, they are in the intensive care unit, they think they are better, so they go back to the normal room in the floor, and then within 2 days they bounce back. So that's one of the measures they have to keep track of. And it's, so it was very easy to specify that in the tool. So the next step, and I won't say too much here because we actually didn't go very far, and anyway, I'll talk more about other things. So we looked at similar. So when I made the point here I wanted to make to you is just thinking of those events and the temporal event, it could mean many different things to be similar. So for example, if the top one is a target, here I swapped two events. So that it's the same, or you could have something is missing, or you could have some time difference, things switched around. So what does it mean to be really the same? And then practically it depends. You can't guess for people or for the task. You have to ask, so let people specify what's important to them and now what's the weight for those differences. And so we did create, and we're not the only one, but there are ways to come up with a measure and then give control panels that let people adjust the weight for each of those component of the metric. But then it gets out of hand to get all those control panels, and we unfortunately we didn't push it further to see that. But I hope we'll come back to that. But just the deal is it's not easy to say what's similar. So the next step was to say, okay, now we have all those records, we could query some, but how could we see the whole picture? So an example is, remember those bounce back? So we are able to search for that particular pattern, but then how do you answer question was, what happened after people arrive at the hospital? Where do they go? Or like, what happened before and after they go to the ICU? How do you summarize this kind of information? So that came up with the concept of a life flow, is the summary of all the patterns of temporal events like this. So I'll show you an example with only four patients, 4 colors. So you notice they all start with blue and they all become purple, and then there is 2 reds and 2 green. So how do we summarize that? I'll click on it. So I group all the colors that are the same, and then we draw a bar. So see, everybody starts with blue, then everybody goes to purple. We realign every time, and we compute the average. So half of them become red, as the other half become green, but later, and then etc. So the advantage is that you could have 1 million patients. If there is only, in that case, there is really 1, 2, 3 patterns, you could aggregate them in a nice, simple way. So I'll show you a little demo. And we use for this demo the data you have seen several times, so all those color triangle. And if everything goes well, I'll try to show you a little example. So this is a little sample de-identified. It's not really the real hospital. Here we go. It's coming. And so here you have the different colors for those items. So you see everybody start with blue, and then they all go to purple. And then about a third go, that's the blue ones, they are discharged alive. So that's everything goes well, they go home. And about a third go to the intensive care unit, and a third go to the floor. But then, of course, typical for visualization, as soon as you find something bizarre, like this is a very long patient. People who stayed back for three months in the emergency, in the floor, and you may want to remove it. You see some people who just went back and forth and bounced back and forth. But we could zoom on it, for example, here a little bit. And so here is what we're saying here. What happened also is I could turn it down. We could show the distribution, because we show the average, but of course you want to see. So all those people who were in the intensive care unit and went to the green floor, of course we take the average, but we could show the distribution. You could show other types of statistics for the duration between events. But of course, we could also bring back the detail view. Let's see, come on. Uh-oh, I don't like that. Yes?
So do you always, is it important to do clustering based on where you're doing some hierarchical clustering, where the event you choose to split the clusters on is always in the order that they occur?
That's right. It's not even, I mean, you could barely call it clustering. It's really grouping the people who have exactly the same pattern are grouped in one band.
But it's not exactly the same because they occur at times.
That's right. The time is average, right?
So in some sense,
it's a sequence. They have the same sequence of event in that case. right?
So is it possible you could have a more significant event that happened later, and it didn't matter what happened so much earlier that you want to cluster on?
But so we're going to get into that. But part of it is you could always remove some events. Like, for example, if I say I don't really care if they went to the ICU or not, I could hide them. So now I'm seeing, or even like actually we could move the floor, and now I'm looking at all the people that came to the hospital, if they left alive, they are blue, or they left dead, they are black. So by deciding which event you include in this, the way the display is, you simplify it by saying what's important to you. And if the order doesn't matter, so you could do a lot by just doing that. So you could find the bounce back easily. If I put the ICU in the floor, the bounce back happen like here. So that's a normal one. Here, those people bounce back, right? But there are some everywhere. So that's where it actually comes useful to use the alignment again. If you really care about what happened before and after the ICU, I'll bring back everything. No, I could say, where is it? So I could align, so I'm here aligning, there was a line on arrival, I could align by the ICU now. So now I'm seeing, of course it helps to make it bigger, but practically there is a big dotted line in the middle with the red ICU, and that tells you the time they were at the ICU, and you could see what happened before and what happened after. So for example, here it's telling me like about a bit more than half came from, actually, in that case, everybody came through the emergency room. Half of them came through the emergency room, the other half came through the floor. And actually, here is another perfect case of visualization helping you finding what's wrong with your data. Somebody was dead before they got to the ICU, right? It always happens. That's the only thing you could be guaranteed that the visualization will help you with. You will find bad data. So here's that's right. And in that case, it's allowing people to decide what they want to align by and what are the attributes, the event types they want to see. That gives them a lot of flexibility. I think that's all I wanted to show on this one. Alors, so I'm switching back to my slides. Doop, doop, doop. And we didn't need the extra video. So now I'm going to spend a little bit more time on the newer work we are doing. And we keep changing name. I'm sorry. Ben Schneiderman insists on giving a new name every time there is a variation, and a new student, he gets his own name. So now it's called event flow. And so the next step was to say, until now we've done point events. But sometimes it's really important to deal with intervals. So you could have taking a drug for a certain time, or being on a diet for a while, or a shot having an effect for a long time. And sometimes it's really important. So we thought, no problem. We could put those points, and we'll put some arrows, or put something on the display, no problem. And the summary kind of worked too. You could see like the people at the top here. It's just a picture, but they took in that case, red is drug A, and blue is drug B. And then the green one is a stroke. So those people took drug A, they had a stroke, and then the drug B. And you get an idea for all the percentage. There is those people who took drug A, had a stroke, but they never took drug B, and so on. So the good news is it kind of works. We have some problem when interval overlaps. So far we merged the colors, and it kind of worked, but we know we're gonna have to do something else. But the good news is that our users have been thrilled to even being able to put like 2 or 3 events at once and see the overlaps and all. So we are okay for a little while. But that's what we are going to be working on now, is find better ways to summarize those interval overlaps. So our current partner for this is the Army Pharmacovigilance Center, and they are dealing with drug data. And they use statistical software, and it's really hard. So finally, it's really that weird feeling that they are looking at their data for the first time. And they have questions related to this. If there are, I know you may have had medical folks in the room, so there are certain drugs misprescribed. So you don't have to read the detail, but there are some red drugs here that are more potent than the other ones. And what they are supposed to do is you should never start with the red one. You're supposed to have the blue one and the green one, the yellow one, and then eventually move on to the red one. And they want to see if there is a step-up effect and a step-down. So their data looks something like this, and that's even only a few patients. So what we're going to have to do also is find some ways to simplify that display. And we have done some of it, but it's still a long way from being to that. It works. But what was interesting is that immediately they could align by the red drug, and they could see that so many of those patients started with the red drug right away. And they did take in consideration, like there was a certain time before, so it's not the patient that were just moving in their system. And so they were like, oh my God, this is not possible. It must be because it's only a sample. We were not looking at the million patient. But when they saw it, they went back to the calculation, and it was indeed actually the same effect that people are not doing, a lot of patients are not doing the step up. So it was, a pleasure to see what the effect it had. But eventually you could clean up aggregate. We have tools so that you could, when there is a little overlap, we merge them in multiple events. When there are small gaps, we merge also and things like this. So you could simplify and still see a lot of things here. So the good news, they were able to see that, we were able to simplify the display. But again, they were dismayed by the fact that there are few people that get the step up, and then even the step down, only a little bit of yellow and green in places where they were expecting to see a lot more. So maybe I'm going to use the rest to really have a discussion with you about what we're struggling with now is how do you deal with making people specify those intervals? It gets really tricky. Practically what we did is we said, oh, no problem. We know about Allen's multiple ways of having intervals and the way to query them. So we implemented a bunch of them. And then people got really confused. There were so many options, so many ways. We start with the interval. We allow people to specify constraints between beginning and end and all. I won't get into the detail, but practically what happened is after hours of spending time with the clinical researcher, really, we could see they were really struggling with those queries. So if you have any good idea, that's great. But just I'm interested in your feedback about those difficulties. We could see four main difficulties. And because we saw that, we ran a study where we gave people queries like those examples, and we asked them to draw it on paper. So they would just draw things. And so one of the first things we saw is that people would think of a query like, that's my drawing for what they were thinking. I want something where there is drug A and there is a stroke during drug A. But practically, they would specify it like this, as a beginning drug A, stroke, and drug A. And so they would end up generating queries on the system that there were a lot of false positive because they would get the third example here. So what we found is that we decided not to allow people to talk about beginning and end of a drug, but we have to force them to specify a drug as an interval, as a whole interval, to avoid those errors in specifying. The other difficulty is even more, we didn't think about it. It just shows that even though we've done user interface for a long time, we never thought people would do this. How do you say that you don't have a stroke or there is an absence of an event? So to specify the presence was already hard, but we got it right now. They could say specify stroke during drug A. But now, how do you say that there was no stroke during drug A? And people would draw something like this. Then, of course, they would get everything because it doesn't. They are not. They were specifying the absence as by not drawing it, and of course, they would get completely the wrong result. Or they would do a stroke after drug A. They were trying to say no stroke during A. So that was a way to say it's okay to be outside, but it's not in it. And again, it would get you completely the wrong results. So we have to find a way to force people to specify the absence, be more specific. So that's where we're dealing with. How do we steer them? How do we make them really specify exactly what they mean by absence? Oh, that there is an absence. And then the next thing say, they also get confused about even if you force them to specify it, there are still some errors that come in. So specifying no stroke after a while, we could make them do it properly. Like you have drug A, and then no stroke after drug A. But practically, that's what people were thinking when they drew this. They really were thinking no stroke after drug A. But if you let them draw this, we're going to find all the patients that had no stroke even at the wrong time. So there is a lot of implied meaning in those queries that people draw that they don't realize is going to give them completely the wrong query. And then for interval, it got a lot more complicated. So it was, I'm sorry, it's a lot, but even me, I've never had to explain it. So we are still struggling to find a way to explain this properly. But if you specify, if you want a stroke and no drug A, like this, that means it could happen anytime. So if at any time during the record there was a time where they didn't take drug A, it would work. It would be returned as a hit to the query. While in some time you want the drug A to be, they had a stroke and then they didn't take drug A. But sometimes it's the other way. You want, they had a stroke anytime when the patient was not taking drug A. So there is many ways that people, you look confused. And I am confused too. It's very hard to explain, but we keep seeing those issues of people misspecifying what they were really trying to say and wanted. So in that case, the effect is we want to frame the actions, force the choices really about what they really want to say. But go ahead.
Who are the people you tested on? Were they kids? Were they doctors?
No, but we're a mixture. Originally, it was all with the clinical researchers, really. So sometimes I'm doctors, sometimes epidemiologists. And then, so because we were confused, found that we could see there was some confusion, we did that study with generative, asking people to draw on paper, and that was with grad students. So, but it confirmed that really, like the most striking is the absence. No stroke during drug A, and people don't even draw the stroke because, it's not there. So, of course, that's what I want. So, it was really striking, even grad student in computer science. So, how do we avoid this in the user interface? So, I can't tell you if it's completely working, but we have good evidence that it seems to be helping. We separated the interface in two parts. There is a basic interface, and then there is the advanced interface. And the basic interface, again, it makes things look wrongly simple. So practically, we have a subsequence mode, which is very similar to what you saw in the earlier prototype, where you just, with the menus, you select, I want this, followed by this, followed by this. But in this case, it includes interval. But the trick here is to separate the subsequence from the interval, from the overlaps. Because practically, it looks the same in the specification, but it has completely different meaning in the results. So for example, here, it's a subsequence. Really, I have drug A, no stroke, and then drug B. And all those fit. Right? That is a subsequence. Well, the other one, it looks the same, but I'm saying I want the overlap. So I want drug A, no stroke during the drug A, and also drug B. So the drug A and drug B overlap, and there is no stroke at that time. So again, here is what the SQL query looks like for specifying this. It looks trivial, really. Right? So that seems to work, and it answers a lot of questions. So it doesn't do everything, but it's a nice way to guide people to specifying only things that will get them the result they really expect. But then we did also the advanced interface, where we allow people to specify. So what they do, actually, I think I have it there, but I haven't really used it much. And then we did some usability testing on it, but not too much. So you have a space here where you could specify, let's say, what could I specify? So the stroke, again, so I get the stroke, and it forces you to say, do you want it or you don't want it? So right away, we steer them to say, if you don't want it, you better say it. And then, so in that case, I want a stroke. I could just put it there on the timeline. And if I don't want something, I click below. Those were suggestions for more usability study. So if I want no drug A before the stroke, so I don't want it, and what it will do is it will use span automatically to the nearest event so that it's clear where the no drug A occur. and it's not everywhere. You could choose different options, but at least it forces you to specify things that match what they, by default, were saying when we didn't guide them, what they thought it would be, and etc. And then when you search, it well, say, well, I could put another one. Wow. So what we do here, we specify the matching records, the one that match are at the top, the one that don't match are at the bottom. So, and then we'll use, doesn't quite work yet, but now we order it by similarity. Now we don't use any fancy similarity, but the idea is that you would bring to the top the things that are closer to the queries they specify, so if it doesn't quite fit what they wanted, it would hopefully will not be too far, and they'll realize that it's not exactly what, it didn't return what they wanted. And that's one thing we had noticed on an earlier version, where at first we didn't separate the things that matched from the things that didn't match. We just ranked everything by similarity. And people didn't like that. They wanted clear saying, okay, what match and what doesn't match. So we added that clear separation. On the other hand, we know people really like to draw their queries like this. It feels more natural than using those painful little menus. But the menus are very constraining, and you're going to get something that's more likely to be correct. So there is that endless design conflict here by making things very simple that don't look any fancy, but are more likely to guide you. So we encourage people to start with those simple ones, and then when they graduate, they could try on the more advanced query here. And I think we want to make sure there is time for questions. I could show you more things, but I'm going to stop here for now, give you the acknowledgement here, and ask for questions. Thank you. All right. Yes.
Scalability is a big
Ha!
issue.
Yes.
So you're looking at hundreds. You're looking at hundreds of. I don't think this is hundreds of records when really
Right.
they may want to look for thousands of records.
Yeah.
Tens of thousands.
Oh, absolutely. So. But so, I mean, we do have ideas, right? That's right. What's interesting is even just to see where the problem lies is complex. Like we always get the question for live flow. Like in principle, the display itself scales because it aggregates. So you could have 1 million, even if you have 2 sequences only, you could have 1 million at the top, 1 million at the bottom, and we could say it aggregates. But typically what happens is that the sequences don't always aggregate. So like the example we showed at the beginning, like the hospital move within the hospital, that aggregates very nicely because you could only be at one place at a time. There were so many places you could be. That's pretty good. The drugs, it gets completely out of hand. So obviously, because the patterns don't aggregate, it's really interesting. You could feel like, it's like your fingerprint. The record of all the for people who take a lot of drugs, the record of all your prescription is like your, your fingerprint. They all look different. So clearly, we know we're going to have some problem. And so what we're doing now is looking at ways to aggregate the low-level patterns to simplifying. So looking for motifs. It's like people who are mostly taking this drug, but they have another one in the middle for a short period of time. We're going to simplify that. So how we do that is not quite clear. And obviously, there are other more computer sciencey techniques and algorithm and all this. And I wish we'd work on it. I can't speak about those, but we have colleagues that are interested in it, and we're just sending proposals around to work on that. But you're absolutely right. What's funny is that it's not that simple. Sometimes it aggregates wonderfully, and sometimes it doesn't. Yeah.
A related question to the scalability, actually, 2 kind of questions. One is when you say you do, thanks. When you do aggregation, so even for the simple ones, you may still have a lot of matching records, right? So when you say you do aggregation, do you mean you do aggregation after you have found all the raw data, then you aggregate before you display, or in the query processing, you have some clever way of doing the aggregation while you are retrieving the data, you know what I'm saying? So this has significant implication on the efficiency and scalability of your query, right? So that's the first question. Second question is, for all the the cute things you have shown here, which is very nice. When you do the query, when you actually translate them to query, do you translate to SQL statement, or you actually have specially designed index structures
Right.
to facilitate your query answering?
So that's clearly not my area. I'm the one who spend the time with the users to make sure it's suitable. But I know some of the answers. Like I know they don't transfer into SQL. They have a special data structure that was shown to be more effective to handle larger queries. The work was done mostly with Lifeline 2. So the first tool you saw, there are papers that describe those data structures and mechanism. And for the second one, for live flow, we're only at the stage where we are trying to identify where are the particular spots where it really hurts most and brings the response down. The other thing
For the aggregation.
Right.
So what about the aggregation? Do you do aggregation only at the end when you have retrieved all the raw records, or you do aggregation while you're kind of...
Because every time you do anything in the interaction, you have to recalculate your summary. So practically, they are really done on the fly. Almost every time you change, if you add a record type or remove it, it has to recompute the summary. So they are done locally. And that's clearly why it's limited. Practically, again, we're not saying that it solves all problem. What we have seen is that typically people tell us, oh, I have millions of records. And then they want something that is the first small little step of querying, bring it down to something reasonable we could load. That's what happens very often. So at least there is a slice of all those problems that we could address. And with more future work, we'll scale up, hopefully. Yes?
So do you think...
Or maybe I should give a chance to the person in the back. So medical, actually, I mean, maybe it's not a good answer, but the answer is that the tool itself is completely ignorant about medicine, because as I was saying, it could deal with any type of event. That comes in it. Yes. Right. Exactly. Right. Mainly the data format is trivial. It's really event type and a timestamp, and then some attributes. I didn't show, but you could add attributes and filter by attribute, show distribution, and so on. But so that's why we could load data from the highway management folks or data from student records. It doesn't know about medicine. It just knows about the event types. Right. So for all the people who have worked with, they extract some data out of their database into our format and reload it in our tool. That's how we do it. Sorry, next time, and then next person.
So you have these ways of constructing queries where the user builds them up incrementally, where they add one part and then they see how it reacts and they add it.
I mean, they don't have to, but typically that's what we see people do.
I'm wondering if you get any bias in the types of questions you ask and potentially the types of answers you get to certain questions when you build up these queries in a way that's incremental, as opposed to kind of thinking through what the queries you want first and then specifying it.
But I mean, I would say it's both. It's more like typically people come with a very specific question. Like the first one that was clear, they wanted high within 14 days of the the radiology contrast. So that's already two event queries and a constraint. And they came with that, but then as they specified it, they realized there were other things that they had not thought about it. It's not thought about. So I think it's inevitably going to be around. So you make queries, you see the result, and you refine your query. So typically what happens is if you don't have the visualization aspect, you just run your statistic practically. You run the query, run the statistic, and you have no clue that you included patient that you should not have included.
So I'm asking, do you think there's a danger of biasing what looks like our outliers? So by trying to eliminate what looks like outliers at the beginning, when you're building up this query, and then as you keep building up the query, you're throwing away more and more outliers, and perhaps these outliers are actually a group of patients which is significant, but you filter them out because of this incremental nature of how it's constructed.
But I mean, I could see your point that there might be. I mean, both ways have their possible bias. I think the typical current bias is to run numbers without really finding those outliers, and then you realize later that you should have removed them. So that's right. We want both. Yes, and I think yes. No, that's right. You were first. That's right. Yes. Right. So yeah. But so the question is really about another aspect of scalability is you have 40 different drugs and event type really. So clearly the limitation is the number of event types. So what we've seen people do is, and the tool allows you to do this. We call it the data kitchen, where we manipulate the data a little bit before we load it in there. So you could group different types of drugs in that case and put them together into a larger category. And so the LABAs, for example, that's what happened. They grouped multiple brand of drugs into one higher class of drug. But you're right, this is yet another way of problem with scalability. Yeah. Yeah. Yeah, it's interesting. Mm-hmm. Yeah. Yeah. Right. So the question, trying to repeat for the recording, but the question is: have you asked people to type the query? If I assume you meant in natural language, right, or even coded. So a restricted language. So in this case, we have not, but we've done cases like this in the past. So the natural language is very frightening here because I think people will make other mistakes. Like just. I mean, we haven't done it here again, but like the ands and or being the perfect example where people always get it wrong and they specify the wrong thing and then they are very surprised for the results. We had also other experiments where we could see, that was in the good old time of the home finder. I don't know if you remember, where it was the dynamic queries, where it was comparing dynamic queries with typing. And that was with a Wizard of Oz type of experiment where there was actually a person on the other side that was actually doing the query correctly as people were typing in English. So there was no problem of really understanding the query. But then we could see that it was slower and that it was that people didn't trust the enter, and they would rewrite it a different way and reformulating their query slightly differently to make sure it would get the same result. So there is a lot of other things that come into play with the natural language. I mean, not to say that it's not appropriate. Like on the web, clearly they have been able to do magic with the natural language specifying of queries because somebody else had already answered the question. Now that there are a lot of question and answers, they could map those queries in natural language. But anyways, again, I'm not saying it doesn't work. In this case, I bet we'll open another can of worms with misunderstanding of the natural language. So I wish, I want to do it too. But you're right, let's remember that sometimes it really works. What, one more? Right. Now in that case, we don't get into that. You're right. There is no statistic being calculated in those values. Right. Yeah, so actually that's a good point. That we don't do that, but that's one thing I would really like to be able to do next is when you do a query that it would automatically classify the variation of the results. But let's say the things that don't match, it would automatically classify like by similarity, really. So it is also based on clustering and finding, see, all those have almost your query except this which one, and this one has more of those, and this one is missing this. So that would be wonderful, but we're not doing that. Yes. Right.
Catherine, for a very interesting.
Right. Thank you. All right. Thank you. And all those tools are